Section 3.1 introduces the terminology, and then 3.2 introduces the relationships that you need to know about those specific parts. Okay? So we'll start here with some definitions and relationships. This section is going to be covering the relationship between lines and angles formed on the lines. Okay, so let's first talk about different kinds of lines. So if you have two lines that never intersect but are coplanar, okay, they're called parallel lines. It is key that you use this description coplanar. Okay, so if you have two lines that fall on the same plane that never intersect, that means that they're parallel, and parallel lines have slopes that are equal. Okay, so when you go for one of these lines here, if the slope is A over B, then the slope of the parallel line, the symbol for parallel is just two vertical bars that are literally parallel to each other. Okay, and so the slope of the parallel is going to be the exact same thing. So whatever the rise of A over the run of B is the same for both lines if you're dealing with parallel lines. Okay, perpendicular lines will also be coplanar lines. And these are going to intersect at right angles. And for perpendicular lines, the symbol for perpendicular is that upside down capital T, which again is an illustration of two lines that are actually perpendicular to each other. They form the right angles. And the slopes of perpendicular lines are going to be negative reciprocals. What that means is if you have a line that is perpendicular, the slope of the perpendicular line, given A over B is the original slope, is going to be opposite and reciprocal. So flip the fraction, B over A, and change the sign, and that's going to be the slope of your perpendicular. So if you look at your original line, parallel lines have an equal slope, perpendicular lines have a slope that is a negative reciprocal. The other way to think of it is that the product is -1. So the product of a slope, or the product of the slope for the original line and its perpendicular will be -1. And then the final type of coplanar lines are called coincident lines, and these are just lines that represent the same thing. They're superimposed on top of each other. And when you're talking about the equations of these, the equations are the exact same. Okay, so we talked about systems of equations, right? We went through that in the algebra review. And so when you look at systems of equations, parallel lines are the ones where you're going to get a system where you get something like 0 is equal to 3. You're going to get an equation that is not true, and it's going to be false. Perpendicular lines, for these you will find the slopes being negative reciprocals. And then coincident lines are the ones with many solutions. Infinitely many solutions, it's the same line. The last scenario here, the last type of line pairings is called skew lines. And skew lines also, just like the parallel lines, they never intersect. The difference is that these are non-coplanar lines. And so skew lines are lines that don't even fall on the same plane. Now, you don't specifically have to say that they don't intersect. I'm going to write that here, but in parentheses, because the fact that they're non-coplanar, it includes the relationship that they're not going to intersect. Okay, so notice that here you have these two flat planes, and the planes, let's say, are parallel to each other. and there's lines contained on those planes that aren't parallel to one another. Okay, but it would be kind of like these two pens here. If you had them, even if they're this close, there's never a scenario where they will intersect. These would be examples, if you extend them infinitely, of skew lines. Right, so what I want you to see, or I want you to try, is can you find, based on the box that represents space right there, 3 dimensions, can you identify which ones are skew and which ones are parallel from the pairings given? So see if you can find that just based on the definitions. Again, I know I haven't specifically drawn in examples on a 3-dimensional representation, but I want to see what you can pick up just from what the definitions say. So sketching what you have, or sketching the angle pairs, is a helpful thing. So I'm going to sketch each of these as I identify it. Okay, and this one actually starts off with one of the tricky ones. Okay, well, we're looking for skew here. So when you look at BC or CB and HE, if you look at those lines, and now even though they don't fall on one of the faces of this box that's used to represent space, can you contain both these lines in one single plane? And this is the tricky part. If you took this plane across here, this wedge, if you took a slanted flat surface and created 2 wedges out of this box, is this right here a plane? Yeah, it's not one that's given to you, okay, and that is the tricky version. So those are coplanar points, okay, which means that this is not skew. This one, these are parallel lines right here. Okay. So if we look at the next pairing, GC, which is here, and EA, notice that that's the exact same thing, right? If you created a plane from this diagonal, this right here, even though it wasn't drawn in to start with, that is a flat surface, a plane. And so those 2 lines, AE and CG, are going to also be parallel to each other. They could be contained in the same plane. Okay, what about FB and EA? Those are both in that front facing plane, and they never intersect, but because they're coplanar, they would be considered parallel. Then we look at FB and HE. Can those 2 lines be contained in the same plane? No. So this is a scenario where you have skew. So that would be one of them. And we look at the last pair, CB and HG. Are these 2 lines that can be contained in the same plane? No. Do they ever intersect? No. So those would also be considered skew. Okay. And so if you just look at them, evaluate each pair separately, you can identify the pairings you're looking for. Okay. So when we look at the parallel ones, so here we have FB and HG. Are those parallel to each other? No, they never intersect, but they're not parallel, so those would be considered skew. Now, keep in mind, like when you look at this right here, so everybody see that is not the intersection of those 2 lines, right? The point on that horizontal line is in front of the vertical line. The vertical line has some depth to it. So make sure that you can kind of imagine the perspective of these 3-dimensional representations on 2 dimensions. Okay, next we have FB and CG. Are those parallel lines? Yep, they're in the same plane. They never intersect, so yes. FB and HE. Are those parallel lines? Again, they never intersect, but they're not on the same plane, so these would be skew. Next, we have HG and EA. Would these be parallel lines? No. Again, this is not an intersection. Okay? The horizontal line sits in front of the vertical line, but they cannot be contained in the same plane, so those would be considered skew. And then the final example here, FB and EA. Those are both on that front face. And so these would be, yes, parallel. Okay, and so that's what you're looking for when you're evaluating skew and parallel. Okay. So they're the same definition as far as they're lines that don't intersect, but the parallel lines are when they're coplanar, and skew is when they're not coplanar. Right, so that was just being able to identify from the exact same type of question that the example showed. Right, there's a couple postulates that relate these types of lines, and again, these are just there's not really a bunch of problems having to do with this. It's just a relationship that exists in this type of Euclidean planar geometry. But the parallel postulate states the following: that through a point not on a line, there's one and only one line that's parallel to a given line that passes through that given point. Okay, so that's the parallel postulate. I'll write it down in words here. But through a point not on a line, there's one and only one line that's parallel through that point. Okay, so through that given point P, there's only going to be one parallel line a parallel line to L. And the perpendicular postulate, same idea, but now through any given point not on a line, there's one and only one perpendicular line that can be drawn to that line, or through that point. And so wording is almost the same, just change parallel with perpendicular, but through a point not on a line. There's one and only one line that's perpendicular to the line through the point. And remember the symbols for these, parallel and perpendicular, model what the definitions are. Okay? So the symbol for parallel are two parallel lines. The symbol for perpendicular are two perpendicular lines. Right, so that's the definitions for the different lines that you're going to see. The next slide is the definition for the angle pairings that you're going to see with regard to lines that intersect. Okay, so at this point, when we go through this first set of material, here we're just naming these angle pairs. We're not talking about specific relationships that exist between them. When we transition into 3.2, which we'll do here on the slide right after this, we'll start talking about what are relationships between these types of angles when lines are parallel. Okay, but right now, you're just identifying what they're called. So when we're naming these intersecting lines, okay, so if we have intersecting lines, this right here is called the transversal. So the line that intersects other lines or multiple lines is called the transversal. And so that's a specific term that's used. And so when you draw a transversal to multiple lines where it intersects other lines, it creates these angle pairings that you see numbered here, 1 through 8. Right? And depending on which angle pairs you choose, they have specific names. So if you take two angles that are on the same side of that transversal, okay, and when you're looking at this, we're going to be looking at two different locations. Okay, so first, this location here is called the exterior. The exterior falls outside the two lines that are being intersected. And then you also have this interior. The interior falls between. Okay, so when you look at these angles, 1, 5, 4, and 8 are exterior angles. And angles 2, 6, 3, and 7 are interior angles. And so again, when we start naming these, they're going to be named based on where they're located both interior and exterior, as well as with regard to where they fall compared to the transversal. Okay, so corresponding angles are going to be a pair of non-adjacent angles. And so this is basically going to be the start to each of these definitions here. But corresponding angles are non-adjacent angle pair that are on the same side of the transversal. One in the interior and one in the exterior. Okay, so angles 2 and 6 right here would be considered corresponding angles. Okay? They're on the same side of the transversal. One is in the interior, angle 6, and one's in the exterior, angle 2. Okay, the next angle pair that you need to be aware of are these angles 4 and 5 here. Angles 4 and 5, they both fall in the interior of the two lines being intersected, and they're on opposite sides of that transversal. Okay, so once again, this is a pair of non-adjacent angles. And they're on, I'll put it as far as, or in the order of their name. So it says alternate, so they're on opposite sides of the transversal. And they're in the interior. Okay, so notice the name gives it away, right? Alternate or opposite, interior. So they're in the interior, opposite sides of the transversal. Okay, the next angle pair type here you can see, and if you had to describe these, they're angles that are both in the exterior. They're on opposite sides of that transversal, so it should make sense that they would be a pair of non-adjacent angles on opposite sides of the transversal. And this time they're in the exterior. Okay, the last angle pairings that have a specific name to them are going to be both in the interior and on the same side of the transversal. So here you have this pair of non-adjacent angles on the same side of the transversal. And they're in the interior. And so this text that you guys use calls these consecutive interior angles. And in the text, most of the texts that I've come across, they've been referred to as same side interior angles. And so these just means the same thing. You can choose either one. It doesn't matter. You might find that in some of the problems or some of the wording, it might ask you for same side interior angles. I tried to change everything to consecutive interior angles so it was consistent with what this text teaches. But since, how many of you guys have read the text? Or read the text? Have opened the text? Ever refer to the text? The fact that you guys really don't, and I know that, and it's not, you're not the only ones. This has been going on since like 2005. That students just use their notes and they use the homework, and that's really about it. But if you looked in the text, these would be called consecutive interior angles. Like I said, you might come across problems where I have it labeled same side interior angles. If that's the case, like that's what it means. Okay? But you can see on this example here, it looks like I have changed that, okay, but expect either one. All right, so using the diagram on the right with those 8 angles, I want you to see if you can identify what would be the angle pairings labeled right here. These naming conventions is like how to describe the angle pairings. Okay, there is no inherent relationship, okay, because when we get to 3-2 on the very next slide that we talk about, it is true that angles in that first example, angle 2 and 6 up on top on the for the definition of corresponding angles, the angle 2 and 6, the way that they're drawn right there, they are not equal to each other. But if those lines were parallel, then angle 2 and 6 would be equal. And so we are going to be talking about a relationship that exists when lines are parallel or to demonstrate that lines are parallel. But just because something falls into these categories, it doesn't mean that they're always equal. These are just the names given based on where the angles are with regard to the transversal and whether they're in the interior or the exterior of the two lines being intersected. All right, so if we look at angles 3 and 6, okay, are they on same side or opposite side of the transversal? Opposite, so alternate. And are they in the interior or exterior? So these are alternate interior angles. Okay? What about 4 and 5? So if we look at, oops. I'll erase those. So what if we look at angle 4 and angle 5? Same side or opposite sides of the transversal? Opposite. In the interior or exterior? Exterior. So these are alternate exterior angles. What you might see for these alternate interior angles might be labeled AIA. Alternate exterior angles might be labeled AEA. And we'll talk more. Usually those abbreviations will be for the specific relationships that we'll see in 3.2, but just again, if you happen to see those abbreviations, that's what it stands for. Okay, if we look at the next pair here, angle 6 and 1. So here's 6 and 1. What type of angles are those? They're angles formed when two lines intersect. They're not adjacent to each other, so these are vertical angles, VA. So we have an angle pairing name for that. Angle 6 and angle 8. This is the one that tends to be the hardest simply because the name of it doesn't specifically tell you what it is. Okay, so corresponding angles, or if you recall, are angles that are on the same side of the transversal as 6 and 8 are. One in the interior, like angle 6, and one in the exterior, like angle 8. And so these are corresponding angles, CA. Next, angles 2 and 3. What type of angles are those? Consecutive. They're same side, both in the interior. Okay, and so that is consecutive interior angles or same side interior angles. So I believe the abbreviation, even if we use consecutive interior angles, I will still have it abbreviated SSI. The same side interior represents that. Okay, angle 6 and angle 4. Okay, they're on opposite sides of the transversal. One in the interior, one in the exterior. Well, the only one that has that is corresponding angles. So here, the corresponding angles have to be on the same side, so this is none. Right, this is no other answer choice. And then finally, option or angles 4 and 3. And what type of angle pairs is this? These are angles formed when two lines intersect and they're adjacent to each other, so they are a linear pair. There's no abbreviation for that, just the phrase linear pair. All right. So these are just the names of the types of angles. When we move to the 3.2 part of this homework, which is this next slide, now we're going to start talking about these relationships. Now, they're called theorems. The reason they're called theorems is if you look in your book, they do give you a link to the proofs to demonstrate that these are true. In some classes, or historically speaking, before you actually use these as theorems, you actually go through the proof. But in this class, the proofs are de-emphasized. So the proofs are there in the book if you want to look at them. Theorems have to be proven, so that's why they're contained. But in these relationships, we're going to talk about if you know a specific relationship between these angle pairings, then you know that that the lines have to be, or that the if the lines happen to be parallel, then the angle measures have a specific relationship. Okay? And so here, when you look at this, all of these are going to be begin with if two lines are parallel. And now notice the way that this, the structure of this conditional statement. Okay, so if the hypothesis is two lines are parallel, then the conclusion is that the corresponding angles here, 2 and 6, are equal. And so this is going to be abbreviated as CA for corresponding angle theorem. Here, angles 4 and 5, they're on opposite sides. Here, angles 4 and 5 are on opposite sides, both in the interior. So these are alternate interior angles. And so if we begin with the condition that two lines are parallel, then alternate interior angles are also equal. And that'll be designated as AIA. That would be the justification for that. Next, we have angles 1 and 8. Those are opposite sides, both in the exterior. So again, if we begin with two lines being parallel, then the alternate exterior angles are equal. Oops, I need to come back because, oh no, we're good. Okay, so we'll abbreviate that AEA. And then the final relationship is those same side interior angles, or the consecutive interior angles. And so once again, if we begin with two lines being parallel, then consecutive interior angles. And now these ones aren't going to be equal. This is the one sort of different relationship. And instead of them being equal, they're going to be supplementary. And remember, these are also maybe referred to as same side interior angles. Okay, so if it is written as consecutive interior angles or same side interior angles, you might see it either of these. CIA for consecutive interior angles, SSI for same side interior angles. Either of those might be the description that you would be talking about. All right, so I want you to see if you can answer just this first pair of questions right here based on the image above. And can you find what the actual measures will be? If you know that these, if J and K here are parallel lines, remember the marking for parallel is little arrowheads drawn on the image or on the lines. That indicates that they are parallel to each other. And so see if you can find what would be the measure of angle 2 and 7 given the measures on each one. And these are two separate questions. So the numbers reset for problem B versus problem A. So solve each one separately. All right, so looking at this first problem, if you know that angle 3 is 47 degrees, so if we labeled that as 47, and we want to find angle 2, well, what relationship exists between angle 2 and 3? They're what kind of angles? Okay, so they're CIA or SSI, and that means that their relationship is they are supplementary, which means they add up to what? Add up to 180. Again, I anticipated that you remembered that terminology, but if they add up to 180, and so you know that 180 minus the given angle 47 is your answer, and the preview for that will show the solution of 133. Okay. The next part, B, deals with the same image but different measurements. So here, if angle 2 is given as 136, then what would be the measure of angle 7? 2 and angle 7 are what type of angles? opposite sides, so alternate, both in the interior. So AIA means that they are equal. And so it would just be 136 as well. Okay, so do the same thing here with the second problem. The second problem takes this a little bit further in complexity, because now you're actually going to solve for what the measure of angle 1 would be given two expressions. Okay? So here you're going to use the relationship, plug in the correct equations or expressions, solve the given equation, and then interpret that to answer the question. So this is a typical type of calculation question. It's multi-step, right? So it's not just looking at it and doing one calculation, right? It's looking at it, interpreting the relationship, solving for an unknown, and then plugging it back into the correct expression. Okay, so if you know you're dealing with angle 1 as 9x minus 6 and angle 8 as x plus 9, what relationship do those angle pairs have? They're alternate exterior angles, which means they are equal. So if we take 9x minus 6 and set that equal to x plus 9, that's the first part, right? So we labeled the relationships and we used the relationship itself, that alternate exterior angles are equal, and now we solve for x. So if we move our x's to one side and our constants over to the other side, and solve, we get x is equal to 15 over 8. So is 15 over 8 our answer? No, because it's not asking you to find x. It's asking you to find the measure of angle 1. And the measure of angle 1 is 9 times that, 15 over 8 minus 6. And so you can just plug it right in, which would be what I would recommend. And if you do that, it will give you the approximation. Hey, now, this is a case where notice that anytime it asks you to enter an answer, using the exact answer or the calculation is always going to be the most accurate, right? So 9 times 15 over 8 minus 6 is going to give you the exact answer. Okay? And when you look at that, you'll see that it does have a terminating decimal. It is 10.875. And nothing. This isn't a rounded answer. This is it. Notice the question asks you to round to at least the nearest hundredth. Okay? Anytime it asks you to round, you can round to more decimals. Okay? And again, this isn't asking you for the precision like physics does. Okay? So here, because it's a terminating decimal especially, rather than putting 10.88, which would be the rounded form, and it should be marked correct, and you would be doing what was being asked, but especially because it just ends in that third decimal place, just go ahead and write the whole exact answer. Okay? So if it prompts you to round to the nearest whatever, my first recommendation is use fractions or calculations, and then my second recommendation is you can always extend your decimals further than what it asks for. And normally it'll be worded at least. This one doesn't have that in there, but I've tried to write the questions where it says round to at least this many, because it's not asking you specifically to round that. It's just anywhere from, like that is just giving you what the tolerance level is. All right, so these would be two additional types of questions that you would be expected to answer using the relationships of these intersecting lines and angle pairings. So I want you to see if you can find x and y in the example to the left. And can you find what that would be based on the relationships that we just looked at? Remember, you can enter your answer as calculations. It's generally easier to do that. It limits the amount of careless mistakes from copying in the wrong numbers. And it also allows me to see sort of what your thought process is. It's your way of showing your work. All right, so notice these markings right here indicate that these lines are parallel to each other. Therefore, this angle of 73 degrees and this angle y would be considered what type of angles? What angle pair? opposite sides, both in the interior. So those are alternate interior angles, which means they are equal, right? So angle Y is going to be 73. And then what do you know about, so if you know that this is 73 degrees, what do you know about X? Well, together, 63, 73, and X have to add up to what? This whole measure here is 180. So if we took 180, subtract the given measure of 63 and the calculated given measure of 73, that's going to give you what's left for angle X. And if you used that relationship, you would get 44. And again, I don't care if you enter it as a calculation. In fact, that would be my recommendation. Okay, so if you haven't finished this second one, just take another moment, about a minute here, and see how would you answer X and Y given this problem. All right, so looking at this problem right here, the easier question, once again, you see that these lines are parallel based on the markings. So that means that 65 degrees and Y, these are also AIA. And so based on that, you know that Y has to be 65 degrees. That's the easier one to find. And once you know that this is 65, you can find the remaining angle X. And you might have done it you might have used some different ways. There's a number of different ways you can go about doing this, depending on what you're familiar with from geometry. Some of you might know the exterior angle theorem of a triangle and be able to solve it. Some of you might remember the triangle sum relationship and solve it with triangles, but we haven't covered triangles yet. So the way that you're sort of intended to solve this is if we look at this whole angle here and this angle right here, these are also alternate interior angles, therefore they are equal. So that means that 153 would have to equal X plus 65. And so if you entered 153 minus 65, that would be sort of the ideal way to solve this. And when you do, you would get 88 degrees for your answer. And so those would be your two answers. Once again, you could enter it as the calculation for that.